Hello there, and welcome to Deep Space Sleep. I'm glad you're here. Maybe your day felt pulled between too many small obligations. Or maybe your mind has been holding onto a rhythm that feels a little too quick. Tonight, you're stepping into a world where the pace finally slows down, a world shaped not by moments, but by months, by years, by the long, steady breathing of the Earth itself. Because the seasons don't hurry. They drift, they unfold. They open and close like soft pages turning in a book the planet has been reading for billions of years. And whether you came here seeking calm, or simply curious about the quiet cycles that guide every forest, every tide, and every breeze, this moment belongs entirely to you. There's nothing to fix, nothing to plan. Let your thoughts lengthen like the golden rays of late afternoon. Let your breath settle into the same slow rhythm that moves winter into spring and spring into summer every single year without fail. In this video, we're exploring the gentle machinery behind Earth's changing seasons, not dramatic storms or chaotic shifts, but the soft mechanics of sunlight angles, drifting shadows, migrating winds, unfurling leaves, cooling nights, and the planet's graceful tilt as it moves around the Sunday. You'll hear 100 quiet facts. Some about the cycles you already feel in your body without realizing it. Others about the deep, ancient patterns that make our world breathe in ways too slow for the eye to catch, yet comforting all the same. If this helps you rest, you're welcome to subscribe whenever morning finds you. It helps others discover a place to unwind, too. For now, let the year open gently around you. Let the seasons drift past in soft motion. Let's wander into them together. Every season begins with a small tilt that changes everything softly. Earth leans just enough on its axis for sunlight to fall unevenly across its surface, creating gentle variations in warmth and daylight. This tilt doesn't shift quickly. It holds steady, guiding the slow dance of the seasons with quiet consistency. As Earth moves around the Sun, different regions receive light at slightly different angles, shaping subtle cycles of growth, rest, and renewal. Near the poles, sunlight sometimes skims the horizon like a soft whisper, while at the equator, it pours down in warm, steady streams. These differences create the planet's calm rhythms, patterns that return year after year. And as sunlight begins its slow drift across the sky, another shift occurs. One we notice in the lengthening and sharpening of shadows shaped by changing angles of light. Shadows stretch gently as sunlight angles shift through the year, lengthening in winter and shrinking in summer. This quiet change happens because lower sunlight travels through more atmosphere, softening its brightness and casting longer, cooler shapes across the ground. On winter mornings, shadows can feel almost blue, reaching out like delicate threads across frosted earth. In summer, they draw close to objects, warm-edged and faint. These changes aren't abrupt. They unfold slowly, almost imperceptibly, as Earth continues its orbit. The atmosphere scatters sunlight differently depending on its angle, changing the color and softness of the shadows we see. This shifting interplay between light and ground becomes a gentle marker of passing seasons. And beneath these shadowed patterns lies another subtle influence: the slight change in Earth's distance from the Sun that affects warmth in a quiet, understated way. Earth's orbit is not a perfect circle but a soft ellipse, meaning our distance from the Sun changes gently over the year. This variation doesn't drastically alter temperature, but it provides a subtle background to seasonal warmth. During perihelion, when Earth is closest to the Sun, sunlight feels slightly stronger, though winter still holds the northern hemisphere due to tilt. At aphelion, when farther away, the difference is small, but perceptible in solar intensity. These shifts unfold without drama, like a slow inhale and exhale of energy across the planet. Oceans absorb and release warmth in response, buffering climates with deep, steady patience. Land surfaces respond more quickly, adjusting in small increments as seasons shift forward. And while these orbital changes influence the background warmth, a more noticeable rhythm emerges through the gradual lengthening and shortening of daylight as Earth turns steadily through the year. The slow shift of daylight length marks one of the most calming rhythms on Earth. Each day's light changes by only minutes, extending gently in spring and retreating softly in autumn. Long summer days feel like drawn-out breaths of warmth, while winter days gather their light briefly, like a quiet flame. This cycle emerges from Earth's tilt, which exposes different hemispheres to longer arcs of sunlight as the planet moves around the sunday. The atmosphere responds by warming and cooling in slow patterns, guiding winds, clouds, and the daily rise and fall of temperature. People and plants feel this rhythm deeply. Sleep patterns adjust, growth cycles begin or pause, and animals sense subtle cues that shape migration. And as daylight shifts toward equality at certain moments of the year, a special balance appears, marking the transition to the equinox. Equinoxes arrive twice a year, when sunlight falls evenly across Earth, creating nearly equal day and night for every latitude. This moment doesn't happen abruptly. It approaches slowly as daylight length converges across hemispheres. During an equinox, the sun rises due east and sets due west, casting a calm symmetry over landscapes. Shadows behave differently, neither stretched by low winter light nor compressed by high summer arcs. The atmosphere glows with even brightness, as if the planet is pausing between breaths. Cultures throughout history recognized equinoxes as times of balance, renewal, and reflection, guided by the gentle harmony of light. Plants respond by shifting growth patterns, and many animals adjust seasonal behaviors. This poised moment bridges two seasonal energies, marking the quiet handoff from one chapter of Earth's cycle to the next, gently opening the way for the following transformations in warmth, light, and air. Solstices arrive as the gentle turning points of the year, moments when sunlight reaches its longest or shortest path across the sky. During the summer solstice, daylight lingers as if reluctant to leave, stretching into warm evenings that feel unhurried and calm. In winter, the opposite occurs. Light gathers briefly, like a soft whisper, before surrendering to the long night. These extremes happen because Earth leans most strongly toward or away from the sun, creating arcs of light that rise high or skim low across the horizon. Cultures have long celebrated solstices as markers of renewal, harvest, and reflection, sensing the deep rhythm of Earth's orbit. And near the edges of the planet, these shifts become even more pronounced, where the polar circles bathe in light or darkness for weeks at a time, experiencing the seasons in their most delicate extremes. Within the polar circles, sunlight behaves like a gentle visitor who stays far longer or leaves for weeks at a stretch. In summer, the sun drifts along the horizon without fully setting, bathing icy landscapes in a soft, continuous glow known as the midnight sun. Shadows circle slowly, never lengthening into night. In winter, the opposite happens. Darkness settles like a calm blanket, lit only by starlight, moonlight, and the shimmering curtains of the aurora. These extended periods of light and darkness arise from Earth's tilt, which directs sunlight away from or toward the poles across the year. Life here adapts in remarkable ways, moving in sync with this unusual rhythm. And moving away from the poles, the experience softens, blending gradually into regions where mid-latitudes drift between seasonal extremes with gentler transitions. Mid-latitudes experience seasons in balanced waves, drifting between the intense contrasts of the poles and the steady warmth of the tropics. Here, sunlight angles shift enough to create the familiar cycle of spring blossoms, summer heat, autumn leaves, and winter chill. Shadows shorten, lengthen, and soften in recognizably repeating patterns. Temperature swings occur gradually as oceans store warmth and release it slowly, moderating each season's approach. Winds shift direction with calm regularity, guiding clouds across landscapes that change their colors in gentle phases. People living in these regions often feel the seasons as a steady heartbeat, noticeable but never abrupt. And as we move farther toward the equator, the pattern smooths even more, giving way to tropical regions where sunlight maintains a steady rhythm, bringing a different kind of seasonal calm. In the tropics, sunlight stays steady throughout the year, rising and setting in nearly identical arcs regardless of the month. Days remain close to 12 hours long, creating a gentle consistency that shapes life in quiet, reliable patterns. Instead of dramatic seasonal contrasts, the tropics experience shifts in rainfall, humidity, and cloud cover, tied to slowly migrating wind belts. Warm air rises, forming towering clouds that release soft bursts of afternoon rain, cooling the land before sunlight returns. Plants grow year-round, responding to moisture rather than temperature, while animals follow rhythms tied to monsoons and wet-dry cycles. This steadiness forms a kind of atmospheric lullaby, a dependable cadence that contrasts with the more dramatic transitions of higher latitudes. And between these regions, where climates meet and overlap, seasonal boundaries soften, dissolving slowly into blended transitions. Seasonal boundaries dissolve gently where one pattern gives way to another, creating long periods that feel like mixtures rather than clear divisions. Late winter carries hints of spring in its softened light, while autumn lingers with pockets of warmth long after leaves begin to fall. These transitions occur because Earth's systems, air, water, soil, and sunlight, respond at different speeds to changing conditions. Oceans warm and cool slowly, delaying the onset of seasonal temperatures. Plants follow their own internal cues, sometimes budding early or shedding leaves late. Atmosphere shifts unfold over weeks as wind patterns reorganize. All these gradual responses create blurred edges between seasons, turning the year into a seamless flow rather than a series of rigid steps. And through this smooth continuum, Earth continues its quiet orbit, guiding us into the next cycle of light, warmth, and drifting shadow. As Earth moves, light becomes a painter with endless patience. In winter, the sun travels low across the sky, its rays brushing the landscape with gentle hues that feel softer and cooler than in any other season. Because sunlight must pass through more atmosphere at these low angles, it scatters into pastel tones, lavender mornings, pale gold afternoons, and long stretches of blue-tinged shadow. Snow reflects this low light with a quiet shimmer, while bare branches glow faintly like ink strokes against the sky. Even urban streets feel calmer under winter's muted brightness. This low arc limits heat, slowing the warming of air and ground, but it offers a serenity found only in cold seasons. And as the year turns, the sun begins rising higher, its path stretching into broad, bright arcs that signal the arrival of summer's expansive light. When summer arrives, the sun rises in bright, sweeping arcs that lift swiftly above the horizon, filling the world with bold warmth and clear illumination. Higher sunlight angles shorten shadows and intensify colors. Greens glow vividly. Water shines with sharp reflections, and sky tones deepen into strong, saturated blues. Because the sun climbs higher in the sky, Its light travels through less atmosphere, scattering less and appearing brighter and more direct. The land warms quickly, and plants soak in the energy with rapid bursts of growth. Days stretch long into evening, with lingering brightness that feels almost weightless. This high summer light creates a feeling of openness, as if the world has expanded to welcome the season. And yet, as evening approaches, a different kind of light begins to unfurl, one that lasts longer in winter but still drifts gracefully through summer skies. Twilight lasts longer in winter, creating long, delicate transitions between day and night. The sun's shallow angle means it slips beneath the horizon slowly, allowing scattered light to linger in gentle gradients: rose, violet, pale silver, and deepening blue. These extended twilight periods arise because sunlight continues skimming the upper atmosphere long after direct rays have disappeared from sight. Cold air holds stillness beautifully, letting colors settle across the sky like soft layers of watercolor. Snow, ice, and frost catch the fading light, shimmering faintly as darkness deepens. Even cities glow differently under winter twilight, with lights reflecting off low clouds to create quiet, peach-colored horizons. This stretched transition offers a moment of calm between the day's brightness and night's cool silence. And as seasons shift again, dawn begins to soften earlier in summer, introducing warmth long before the sun climbs into its high arc. Dawn softens earlier in summer, spreading gentle light across the landscape long before the sun crests the horizon. This early brightness comes from the atmosphere scattering sunlight around Earth's curve, illuminating the sky in faint blues and pinks, while the world remains quiet. Birds begin to stir, dew glimmers on grass, and shadows loosen their edges as morning grows. Because Earth's tilt directs the hemisphere more fully toward the sun, twilight stretches into these early hours, letting daylight seep gradually into valleys, forests, and coastlines. The warming air begins to rise, forming soft breezes that drift through leaves and open fields. Summer dawn carries a sense of anticipation, light building steadily, warmth slowly unfolding. And as the sky brightens, something else changes subtly. The colors overhead shift with the seasons, revealing how light interacts differently with air, moisture, and dust throughout the year. Seasonal color shifts in the sky emerge from the delicate interplay of sunlight, atmosphere, and changing weather patterns. In winter, colder, drier air scatters light into pale blues and muted pastels, creating subtle, washed-out horizons. Spring brings more moisture, softening colors into misty pinks and gentle golds. Summer skies deepen into rich, saturated blues as warm air rises and particles scatter shorter wavelengths more efficiently. Autumn introduces dust and fine aerosols from dry leaves and shifting winds, adding amber tones that glow at sunrise and sunset. These seasonal palettes unfold gradually, never announcing themselves abruptly but drifting into place as temperatures shift and air composition changes. Each sky becomes a quiet reflection of Earth's ongoing cycle, a canvas painted by light moving through ever-changing layers of atmosphere. And from these changing colors, the next transformations of the year begin to take shape. Refraction shapes warm sunsets by bending sunlight through layers of atmosphere that change density as day cools into evening. When the sun sinks low, its light must travel through more air, scattering shorter blue wavelengths and letting longer red and orange tones drift softly across the sky. Dust, moisture, and temperature gradients enrich these colors, creating warm horizons that feel painted in slow, dissolving strokes. Mountains glow in copper hues. Oceans reflect pools of fading gold, and city windows catch glimmers of tangerine light just before dusk settles. Even after the sun disappears, refracted rays linger, stretching twilight into a gentle afterglow. And as these soft colors fade, they reveal the next subtle transformation of the atmosphere, one shaped by shifting clouds whose brightness and behavior change with every season's quiet patterns and shifting temperatures. Clouds glow differently by season because the atmosphere changes its texture, moisture, and sunlight angles throughout the year. In winter, cold air holds less water, creating thin, icy clouds that shimmer with pale halos or faint pastel tones. Spring introduces more moisture, allowing clouds to swell softly, glowing in tender shades of peach and lavender at sunrise. Summer clouds brighten intensely as higher sun angles illuminate their tops in brilliant white, while thunderheads build with towering shapes that catch warm gold along their edges. Autumn brings a different softness, with low, drifting clouds glowing amber as dust and cool air filter sunlight into gentler hues. Each season paints clouds with its own quiet palette, revealing how light interacts with shifting air. And when temperatures drop even lower, these atmospheric conditions create shimmering effects unique to cold climates, such as the delicate formation of sun pillars rising above winter horizons. Sun pillars appear in cold air when tiny ice crystals drift through the atmosphere, catching the sun's low light and reflecting it upward in a shimmering vertical beam. These crystals act like countless floating mirrors, aligning loosely as they fall to create a gentle column of golden or pink light rising above the horizon. The effect is calm and dreamlike, a winter phenomenon made possible by still air and frigid temperatures that allow ice to form delicate, plate-shaped structures. Sun pillars often appear at sunrise or sunset, when the sun's angle is low and its light glides horizontally through the crystals. Their glow lasts only moments, fading as the air stirs or the sun's angle shifts. And when the pillar dissolves, the atmosphere often settles into quieter patterns, allowing moisture to gather more closely to the ground, preparing the way for morning fog that drifts into valleys and fields with seasonal tenderness. Morning fog settles with seasonal moisture as cool air hugs the ground, allowing tiny droplets to condense into soft, drifting veils that transform familiar landscapes into muted dreamscapes. In autumn, fog rises from cooling soil and still warm rivers, creating layers that move silently through trees. In spring, moist air from overnight rain settles into low hollows, gathering like a gentle breath resting across the land. Fog forms when the air reaches its dew point, letting water vapor condense into suspended droplets that scatter light softly, erasing sharp edges and blending colors into silver-gray gradients. Roads, fields, and forests appear softened, as if wrapped in a quiet blanket. This atmospheric calm guides animals' movements and signals plants to hold moisture longer. And as fog slowly lifts, sunlight returns in gentle beams, revealing the subtle ways moonlight, too, reflects differently through seasonal air and shifting angles above the horizon. Moonlight reflects subtle seasonal angles because the moon's path across the sky changes as Earth orbits the Sunday. In winter, the moon often climbs higher, casting brighter, sharper light that glimmers on snow and frost. In summer, it travels lower, creating warmer, gentler reflections that drift across fields and water with softer edges. The atmosphere also plays a role. Colder air scatters moonlight more cleanly, while humid summer air diffuses it into hazier glows. This shifting interplay influences how landscapes appear at night: mountains outlined in pale silver, forests washed in cool blue, coastlines shimmering with faint, rhythmic highlights. The moon's phases add further variation, with rising arcs and descending paths shaped by Earth's tilt. Each season gives moonlight its own quiet personality, closing the cycle of how light changes through the year and preparing us for the next gentle transformation of air, temperature, and sky. The atmosphere changes temperature like a long, steady breath. Warm air rises gently in summer, lifting from sun-soaked ground in soft, wavering currents that shimmer above fields, roads, and rocky hillsides. As the sun climbs higher each day, its light warms surfaces unevenly, creating delicate pockets of buoyant air that drift upward with the quiet grace of lanterns lifting into sky. Birds ride these thermals effortlessly, circling upward without flapping, drifting wherever the warm spirals carry them. Plants feel this rising warmth too, leaves open wider, releasing moisture that joins the slow upward flow. The rising air eventually meets cooler layers, spreading out like a calm exhale before sinking again at distant edges of atmosphere. And when the year turns and sunlight weakens, the process reverses, allowing cool air to settle softly across winter landscapes. Cool air settles softly in winter, flowing downward like a quiet stream as temperatures drop and daylight shortens. Because cold air is denser, it moves low across the land, slipping into valleys, pooling in hollows, and filling forests with a crisp stillness. Frost forms where this chilled air lingers longest, painting grasses and branches with delicate crystals that glint in morning light. The atmosphere becomes stable, with fewer rising currents and gentler winds that let sounds travel farther through calm winter air. Buildings exhale faint plumes of warmth that drift upward before dissolving, and lakes release thin mists as water meets the cold. This downward flow of air helps create temperature inversions, trapping tranquility near the ground. And high above, the shifting contrast between warm and cold layers begins to influence the jet streams that slowly drift with the changing seasons. Jet streams drift with the seasons as vast rivers of fast-moving air that circle the planet high in the atmosphere. In winter, the strong contrast between cold polar air and warmer mid-latitude air tightens these streams, speeding them up and guiding storm tracks across continents. In summer, temperature differences soften, allowing jet streams to relax into broader, slower meanders. Their shifting paths subtly shape weather patterns, sometimes bringing long stretches of calm skies. Other times, slow-moving rains that linger over landscapes. These air currents flow thousands of miles, yet their influence touches every small place beneath them. Winds change direction, clouds form differently, and temperatures respond in gentle rises or falls. And as the jet streams drift, they carry with them the seeds of larger atmospheric motions, forming waves that stretch across entire hemispheres. Atmospheric waves form long patterns that travel through the sky like ripples across a vast, invisible ocean. These waves develop when air masses of different temperatures meet, creating gentle undulations that shift winds, cloud cover, and pressure systems over days or even weeks. Some waves circle the globe, guiding weather in slow, predictable rhythms that feel almost like breathing. They can bend storm tracks, create pockets of stillness, or lead to long periods of mild conditions. Because they move gradually, their effects appear subtle clouds forming in rhythmic bands, winds drifting in wide arcs, temperatures rising or falling with soft transitions. These waves help regulate seasonal weather, smoothing the shift between warm and cool periods. And as they propagate across continents, they carry warmth downward in spring, helping the ground begin its slow seasonal awakening. The slow warming of ground each spring begins beneath the surface, where stored winter cold gradually yields to strengthening sunlight. Soil absorbs heat layer by layer, warming so gently that changes are almost impossible to detect day by day. As temperatures rise, frozen water within the ground melts, releasing moisture that seeps into deeper layers or rises as soft morning vapor. Earthworms, insects, and roots respond first, moving upward to greet the season. The warming soil releases subtle scents, loam, new growth, distant rain signals that life can begin again. This gradual transition influences everything above it. Air warms slightly faster, breezes soften, and early plants send tentative shoots toward a sun still low in the sky. And as the ground continues to warm, the season reshapes itself, preparing the way for further cycles of rising air, shifting winds, and lengthening days. Heat stored in oceans moderates the seasons by holding sunlight in vast, slow-moving reservoirs of warmth. Water absorbs energy throughout summer, gathering it beneath calm surfaces and within deep currents that move patiently across the globe. When autumn and winter arrive, the oceans release this stored heat gradually, softening temperature swings on nearby coasts and carrying gentle warmth into cold air masses drifting overhead. Even a small rise in ocean temperature can delay the first frost or extend mild days into early winter. Waves become quieter in cooler months, releasing warmth as mist, vapor, and subtle breezes that drift inland. Marine life responds to these long, measured changes, migrating or spawning along paths shaped by shifting water temperatures. And as oceans breathe out their stored summer heat, the air above them settles into new patterns, forming calm layers that sometimes trap cold air close to the ground when winter inversions take hold. Winter inversions occur when cold air becomes trapped beneath a layer of warmer air, creating a calm, quiet atmosphere that feels almost suspended. Because cold air is denser, it settles low in valleys and basins, unable to rise through the warmer, lighter air above it. This stable layering softens winds, mutes sound, and allows frost or fog to linger throughout the day. Chimney smoke rises only slightly before spreading sideways in gentle floating ribbons. Trees stand motionless as delicate crystals cling to their branches. Though inversions can trap pollution, they also create an unusual stillness, as if the landscape has paused its breathing. These moments occur most often in winter when nights are long and ground surfaces cool efficiently. And as temperatures shift and pressure systems move, the inversion eventually dissolves, allowing air to rise once more. A motion that becomes especially important when seasonal monsoons begin their slow, powerful build. Seasonal monsoons build gradually as oceans and continents warm at different rates, creating shifts in air pressure that draw moist winds inland. This process unfolds over weeks, beginning with small changes in sea surface temperature and subtle movements of the intertropical convergence zone. As warm air rises over heating land, cooler, moisture-rich air flows in to replace it, forming clouds that thicken day by day. Early monsoon rains fall gently, soaking soil and releasing earthy scents that drift through valleys and fields. As weeks pass, the rains strengthen, nourishing crops, filling rivers, and cooling landscapes that have waited through dry, hot seasons. The rhythm of the monsoon becomes a heartbeat for entire regions, steady, life-giving, and deeply calming in its predictability. And when the rains eventually retreat, the air shifts once again, carrying the first hints of autumn's light chill across forests and open plains. Autumn air carries a light chill that arrives gradually, slipping into mornings and evenings with quiet subtlety. After the lingering warmth of late summer, cooler air settles in pockets across fields and forests, collecting near rivers and drifting into shaded areas. Leaves respond first, their edges crisping as pigments shift to gold, amber, and deep red. The atmosphere becomes clearer as humidity drops, revealing sharper horizons and softer breezes. Animals notice the change too. Birds gather in loose flocks. Insects slow their movements, and mammals begin preparing for winter. This gentle cooling is driven by shorter days and weaker sunlight, allowing heat to escape more quickly from land and air. Autumn's chill does not rush. It spreads with calm purpose, preparing the world for colder months. And as the days shrink further, summer's memory lingers only in brief warmth, carried by breezes moving through the last quiet cycles of the season. Summer breezes move in soft cycles created by the daily warming and cooling of land and sea. As sunlight heats the ground each morning, warm air rises and pulls cooler air inland, forming gentle onshore winds that carry the scent of salt, grass, or warm stone. By evening, as land cools more quickly than water, the breeze reverses direction, drifting back toward the sea in calm, restorative currents. These diurnal wind patterns shape the summer atmosphere, guiding clouds, smoothing temperatures, and creating rhythmic pulses of motion that feel almost like the earth exhaling. Trees sway lightly, fields ripple in silver-green waves, and lakes shimmer under the touch of these changing winds. Even at night, faint breezes slip across open landscapes, carrying lingering warmth from the day. And as these soft cycles continue, they help bridge the transition into the deeper atmospheric changes that define the next season. Water responds to seasons with slow changes that reshape landscapes calmly. Snow begins accumulating in soft layers when cold air stills the atmosphere enough for ice crystals to grow delicate and symmetrical. Each flake falls at its own gentle pace, settling onto forests, rooftops, and open fields with barely a sound. Over time, these layers compress into smooth blankets that soften every shape beneath them, muffling footsteps and quieting entire valleys. Snow reflects sunlight efficiently, helping keep winter temperatures low while storing moisture for warmer seasons. Animals move carefully across its surface, leaving temporary trails that disappear with the next snowfall. As the season deepens, the snowpack becomes a reservoir of future water, waiting for the sun's return. And when spring arrives, these silent accumulations begin their long transformation, melting slowly into streams that sparkle with the first warmth of the year. Ice melting into spring streams begins with subtle warming, longer daylight, gentler sunlight angles, and a gradual softening of winter air. The top layer of snow loosens first, forming tiny rivulets that slip between crystals before joining larger channels beneath the surface. Frozen lakes crack softly, releasing water that glimmers as it moves toward rivers swollen with meltwater. This thaw is a controlled, patient process, moderated by temperatures that rise just a little each day. As ice retreats, dark soil emerges, absorbing more heat and hastening the melt. The sound of trickling water becomes one of the earliest voices of spring. Weaving through valleys and forests, plants respond instantly, drawing fresh moisture upward, while animals follow these forming streams as they reshape the land. As spring progresses, the melting slows and shifts into a new rhythm, one carried upward again through summer evaporation, rising like mist. Summer evaporation rises like mist when sunlight warms the surface of lakes, oceans, and soil, lifting water molecules into the air one by one. Warm air can hold more moisture, allowing evaporation to increase throughout long summer days. The process is silent and continuous. Thin veils of vapor drift upward, blurring reflections on water and softening the outlines of distant hills. Fields release moisture slowly, creating shimmering heat haze that ripples across open land. This evaporated water feeds clouds forming high above, contributing to summer's towering cloudscapes. Plants join the cycle through transpiration, adding moisture from their leaves into the warming atmosphere. Together, these rising mists prepare the sky for shifts in weather patterns, and as moisture collects in moving air masses, it begins to follow broad circulation pathways, shaping how rainfall drifts across continents along shifting wind belts. Rainfall follows shifting wind belts that migrate with the seasons, guiding moisture from oceans toward land in gentle, predictable patterns. As Earth tilts, sunlight warms one hemisphere more strongly, causing large-scale atmospheric cells to expand or contract. These movements shift trade winds, monsoons, and mid-latitude westerlies, carrying clouds to new regions while leaving others under clear skies. Rain arrives when warm, moist air rises and cools, condensing into droplets that fall softly or gather into prolonged showers. Forests, grasslands, and farmlands depend on these seasonal deliveries of water, responding with bursts of growth or quiet dormancy. Some regions experience dry months followed by sudden renewal, while others receive steady rains throughout specific seasons. And when oceans warm, the air becomes even more moisture-rich, setting the stage for another transformation of seasonal moisture, the formation of storms shaped by warm seas and shifting winds. Seasonal storms form with warm seas when sunlight heats ocean surfaces enough to release large amounts of water vapor into the atmosphere. This moisture rises, cools, and condenses into towering clouds that build slowly over hours or days. Warm water provides energy that fuels these systems, allowing winds to strengthen and rain bands to spiral outward. Despite their power, many seasonal storms begin quietly, a distant darkening on the horizon, a deepening scent of moisture, a soft pressure change in the air. As they approach, landscapes prepare. Leaves turn their undersides to incoming winds. Birds seek shelter, and the atmosphere thickens with anticipation. These storms help redistribute heat globally, carrying warm air toward cooler regions and bringing rain to places that depend on them. And after they pass, the air often clears into calm, washed light, marking the next step in Earth's slow cycle of water and atmosphere. Mountain runoff feeds rivers as snow and ice melt slowly under warming sunlight, releasing water that has been stored quietly through winter's stillness. This melt begins high among ridges and cliffs, where sunlight touches slopes at different angles, guiding the flow into countless small channels. These streams join together in clear, cold ribbons that weave through forests and rocky valleys, carrying minerals and nutrients that enrich ecosystems below. The timing of this runoff depends on temperature, elevation, and the winter's depth of snow, creating a gentle, predictable rhythm that shapes river levels for months. Wildlife relies on these dependable flows. Fish migrate upstream, plants thrive along moist banks, and insects hatch in synchrony with rising waters. As the runoff settles into rivers and lakes, moisture disperses into the air, forming conditions that prepare landscapes for another quiet phenomenon: dew forming during cooler nights. Dew forms during cooler nights when warm, moisture-filled air meets surfaces that have cooled after sunset. As temperatures drop, the air reaches its dew point, allowing water vapor to condense into delicate droplets that settle on grass, leaves, and stones. Each droplet acts like a miniature lens, catching early light and scattering it into soft glimmers at dawn. Dew is more common in seasons with warm days and cool nights, such as spring and autumn, when humidity lingers in the air but temperatures fall quickly after sunset. These droplets nourish small plants, hydrate insects, and create a thin layer of moisture that evaporates gently with the morning sunday. Dew reflects the calm balance between air, temperature, and moisture, an exchange that shapes many seasonal transitions. And as nights lengthen or shorten, These dew-covered landscapes connect naturally to larger bodies of water nearby, where lakes breathe slowly through their freeze-thaw cycles. Lakes breathe through freeze-thaw cycles that unfold at the boundary between seasons, responding gently to changes in air temperature and sunlight. In winter, the lake's surface cools until ice forms, sealing the water beneath in a quiet, insulating layer. This ice thickens slowly, trapping oxygen and preserving aquatic life in a stable, cold environment. When spring arrives, sunlight softens the ice, creating cracks and channels where meltwater sinks and mixes with deeper layers. This turnover replenishes nutrients and oxygen throughout the lake, supporting new life as temperatures rise. The freeze-thaw cycle also shapes surrounding landscapes. Shorelines shift subtly. Stones frost and thaw, and plant life responds to changing moisture levels. These slow transformations create seasonal rhythms that influence local humidity, allowing moisture to drift into the atmosphere in gentle patterns. And as air absorbs and releases this moisture, humidity begins to shift with the seasons in its own calm, wandering flow. Humidity drifts with seasonal temperatures as warm air gathers moisture and cooler air releases it. In summer, heat encourages evaporation, filling the atmosphere with water vapor that softens horizons, deepens the scent of vegetation, and gives the air a gentle weight. This moist air can form hazy afternoons, warm nights, and clouds that build with lazy upward currents. In winter, the air cools and loses its ability to hold moisture, becoming crisp and dry, with long distances appearing sharply outlined in low humidity. Transitional seasons like spring and autumn carry humidity that fluctuates day by day, rising with warmth and falling with nighttime coolness. These shifts influence how clouds form, how plants breathe, and how landscapes feel beneath changing skies. And as humidity moves through these cycles, it guides the formation of clouds that arrange themselves into delicate patterns shaped by the season's evolving atmosphere. Clouds form delicate seasonal patterns as moisture, temperature, and wind interact differently throughout each part of the year. In spring, rising warm air creates soft cumulus clouds that drift like scattered cotton across bright skies. Summer brings taller, more energetic formations, with billowing towers catching sharp sunlight at their peaks. Autumn clouds spread into layered sheets, their colors warmed by dust and low-angle sunlight that turns them amber or rose. Winter's colder atmosphere favors thinner, icy clouds, cirrus streaks, halos, and faint veils that shimmer subtly in pale light. These patterns arise from the interplay between humidity, atmospheric stability, and the sun's changing path across the sky. Each type of cloud reflects a moment in the year's slow progression, forming and dissolving with quiet precision. And beneath these ever-changing shapes, the water cycle continues its calm flow into the next seasonal chapter. Plants feel every small change in sunlight and answer in quiet ways. Leaves unfurl with spring warmth, responding to rising temperatures and longer days through a process guided by stored hormones and gentle shifts in daylight. Buds that remain tightly closed through winter begin loosening, their delicate layers expanding as cells fill with water and stretch into broad green surfaces. Each unfurling leaf becomes a soft sensor, catching early sunlight and beginning photosynthesis in slow, measured breaths. The landscape transforms as branches thicken with new growth, casting dappled shadows that sway with mild breezes. This tender awakening supports insects, birds, and small animals emerging alongside the plants. And as leaves reach full size, another transformation begins deeper within the ecosystem. Flowers, preparing to time their seasonal bloom with the precision and calmness of the unfolding year. Flowers time their seasonal bloom using cues from temperature, day length, and the gradual warming of soil. Some require a certain number of cold days before they can open, while others wait for the perfect balance of sunlight and moisture. When conditions align, petals begin to unfold in gentle spirals, revealing colors that seem to rise from the landscape like soft brushstrokes. Bees and butterflies sense these changes instantly, drifting from blossom to blossom in patterns shaped by scent and light. Longer days encourage stronger growth, allowing entire meadows to shift from muted tones to vibrant, living tapestries. The timing is never rushed. Each species follows an ancient rhythm passed down through countless seasons. And as blossoms fade at the end of their cycle, trees quietly begin storing energy for the colder months ahead, preparing for their own slow transformations. Trees store energy for winter by channeling sugars produced in summer leaves into roots, trunks, and branches. As days shorten and temperatures fall, photosynthesis slows, prompting trees to withdraw nutrients from their leaves and seal off the tiny vessels that once carried water upward. This internal preparation happens gradually, like a soft retreat into stillness. Leaves shift color as chlorophyll breaks down, revealing pigments that have been hidden all year. Meanwhile, underground, roots continue absorbing moisture and minerals, building reserves that will sustain the tree through cold, dormant months. Bark thickens, growth rings pause, and the entire organism settles into a quiet endurance, shaped by long cycles of darkness and light. When energy is finally secured, forests begin their next transformation canopies, shifting colors in sweeping waves that signal the full arrival of autumn. Forest canopies shift colors as sunlight weakens and temperatures drop, revealing pigments that have waited beneath chlorophyll's green glow. Carotenoids brighten into golds and oranges, while anthocyanins form reds and purples that ripple across hillsides like flowing paint. This transformation begins at the canopy's outer edges, where leaves receive the least sunlight, and spreads inward in slow motion. Weather influences these colors. Cool nights intensify reds, while dry spells mute certain shades, but the overall shift remains a gentle, predictable unfolding. Light filtering through colored leaves casts warm patterns on the forest floor, creating quiet tunnels of amber and rust. Animals respond too. Squirrels gather food among drifting leaves, birds search for late-season seeds, and insects settle into sheltered places. Beneath these vibrant canopies, another process prepares for spring's return. Seeds, waiting patiently for the exact seasonal cues that will tell them to wake. Seeds wait for seasonal cues with remarkable patience, remaining dormant through cold, dry, or dark conditions, until the environment becomes favorable for growth. Many require specific triggers: sustained winter chill, moisture from spring rains, or increasing daylight that signals warmer months ahead. Inside each seed, complex biochemical signals activate slowly, preparing tiny cells to divide and form roots and stems. On the forest floor, seeds rest beneath leaves and soil, protected by layers that shift with the seasons. When conditions align, they swell with absorbed water, splitting their shells in quiet determination. A small root anchors downward, while a fragile shoot reaches upward toward light, beginning the next cycle of life. This awakening unfolds silently but steadily, linking one season to the next as new plants rise to join the unfolding year and prepare for further transformations shaped by light and temperature. Roots grow deeper in summer as warm soil invites plants to extend their underground networks in search of moisture stored far below the surface. During long, sunlit days, photosynthesis provides abundant energy that flows downward through stems and trunks, fueling the slow, deliberate growth of roots. These tendrils weave through soil in quiet arcs, feeling out pockets of water and minerals that support the rest of the plant during dry periods. In forests, roots intertwine with fungi, sharing nutrients in vast, hidden webs. In fields, crops anchor themselves more firmly, drawing resilience from deeper layers untouched by daily heat. This downward movement balances the upward reach of leaves and stems, creating the full, steady rhythm of summer growth. And as roots continue sinking into the earth, the plants above take on new forms, including evergreen trees whose needles are adapted to trap winter's scarce and gentle light. Evergreen needles trap winter light by using narrow, wax-coated surfaces designed to gather what little energy the sun provides during cold months. Unlike broad leaves that drop away in autumn, needles stay through freezing temperatures, conserving water and minimizing damage from snow or ice. Their deep green pigments absorb low-angle sunlight efficiently, allowing photosynthesis to continue even on the shortest days. Forests of pine, spruce, and fir glow softly under winter skies, their needles shimmering with frost in morning light. These trees stand as quiet anchors of color when surrounding landscapes fade to brown and white. Wildlife shelters among them, sensing warmth and cover beneath the dense branches. As temperatures rise and snow melts away, the steady presence of evergreens gives way to new signs of renewal on the ground below grasslands, awakening after rains that bring moisture and life back to wide, open spaces. Grasslands awaken after rains with a suddenness that feels almost magical, as dormant seeds and roots respond instantly to renewed moisture. Dry soils soften, releasing earthy scents that rise into the air while tiny shoots push upward in thin green threads. Warm sunlight and fresh water create perfect conditions for rapid growth, allowing grasses to stretch toward the sky in waves that ripple under passing breezes. In many regions, this transformation follows seasonal cycles: monsoons, spring showers, or late summer storms, each with its own rhythm of renewal. Insects hum back to life, grazing animals return to feed, and ground birds weave through the new growth. The entire ecosystem resets with each rainfall, tied to the delicate balance between moisture and warmth. And within this renewed landscape, climbing plants sense these favorable conditions too, guiding vines to begin their warm season growth across trees, fences, and rocky ground. Vines follow warm season growth patterns that encourage them to stretch, climb, and coil as sunlight strengthens. These plants rely on supportive structures, trees, stones, fences, to lift their leaves toward the sun, maximizing photosynthesis during the warm months. Tendrils search the air like gentle fingertips, curling around anything they encounter. As temperatures rise, vines accelerate their growth, sometimes extending several inches in a single day, creating lush canopies that shade soil and shelter small animals. Their growth depends on heat, moisture, and day length, responding to each with subtle adjustments. Some vines store energy in roots during colder months, while others drop leaves entirely before returning with renewed strength. Beneath these climbing webs, the forest floor remains cool and humid, allowing another plant group to thrive in silence: mosses that absorb moisture through the year, regardless of season. Moss absorbs moisture through the year with remarkable consistency, thriving in environments where larger plants struggle. Without true roots, moss relies on its entire surface to gather water from rain, dew, and humid air. This allows it to remain green even during dry periods, storing moisture within tiny leaf-like structures. Moss carpets forest floors, drapes over rocks, and climbs tree trunks in soft, velvety layers that glow richly after rainfall. In winter, it remains active beneath snow, drawing small amounts of water from melting crystals. In summer, It captures morning dew before the sun rises fully. Mosses play a quiet but essential role in ecosystems slowing erosion, retaining moisture for surrounding plants, and providing habitat for insects. Their year-round presence offers a steady rhythm within shifting seasons, bridging the transitions that shape plant life throughout the year. Creatures move with the rhythm Earth sets for them. Birds migrate along shifting winds, sensing subtle changes in temperature, daylight, and atmospheric pressure. As seasons turn, warmer air rises and colder currents form stable pathways high above the ground, guiding flocks across continents with quiet precision. Birds glide through these invisible rivers of air, conserving energy by riding thermals that lift them gently skyward. From great V-shaped formations crossing oceans to tiny songbirds navigating night skies, each species follows routes shaped by ancient memory and celestial cues. Landscapes transform beneath them, forests thinning, lakes freezing, grasslands greening, and still they move forward, driven by instinct older than any map. And when they reach their seasonal destinations, another group of animals prepares for a different journey entirely, slipping into a deep and restful state as hibernation eases their bodies into winter's quiet. Hibernation eases animals into quiet by slowing their metabolism until heartbeats, breathing, and temperature drop to levels that conserve precious energy. Bears retreat into sheltered dens, curling into soft, rhythmic stillness while winter storms sweep past unnoticed. Smaller creatures, groundhogs, bats, hedgehogs, lower their body temperatures dramatically, entering a suspended calm where days and weeks pass without waking. This process begins gradually as daylight shortens, food becomes scarce, and hormones shift to signal the approaching cold. The world outside continues changing, but inside burrows and caves, time slows to a gentle whisper. Snow blankets the entrances, muffling sound and sealing warmth inside. And when the sun returns with spring's first touch, these animals stir from their long rest, emerging just as insects begin awakening beneath warming soil, responding to the season's earliest invitation. Insects emerge with warming soil as sunlight penetrates deeper into the ground, raising temperatures just enough to activate dormant life. Larvae that spent winter buried in stillness begin to wriggle upward, while overwintering adults stretch delicate wings for the first time in months. Ants open their tunnels, bees leave their hives in cautious loops, and beetles explore leaf litter softened by spring rain. This awakening is triggered by soil temperature rather than surface air, making insects some of the first animals to sense the changing season. Their return brings new sounds to forests and fields, soft buzzing, clicking, and humming patterns that echo through warming air. Flowers rely on these early visitors for pollination, creating a partnership shaped by countless seasonal cycles. And as insects take to the air and water once more, fish respond as well, following seasonal currents that shift with temperature and daylight. Fish follow seasonal currents that form as oceans and lakes warm or cool with the changing Sunday. As surface waters heat in summer, nutrient-rich deep water rises in gentle upwellings, attracting schools of fish that feed in swirling, shimmering patterns. In winter, colder currents sink and reshape underwater pathways, guiding fish toward deeper, more stable temperatures. Many species migrate long distances, sensing tiny chemical changes and faint thermal gradients that act like underwater maps. Rivers swell with snowmelt, drawing salmon upstream in powerful yet methodical movements, while coastal waters fill with species returning to spawning grounds. Light filters differently through water in each season, shifting from bright turquoise to muted grey-blue, creating underwater landscapes that feel alive with subtle motion. And in the far north, as fish adjust their movements to the rhythm of melting ice, reindeer begin their own long seasonal journey across snowy plains. Reindeer move with snowmelt in sweeping migrations, shaped by the quiet logic of temperature, moisture, and vegetation. As winter loosens its grip, melting snow reveals new patches of lichen and emerging plants that draw herds across tundra and mountains. Calves walk beside adults, stepping carefully on softening ground that holds the imprint of countless migrations before them. Reindeer can sense where snow will melt earliest, using wind scents and subtle shifts in light to guide their path. Their hooves adapt to the changing terrain, broad and steady on snow, sharp-edged and nimble on exposed rock. Birds follow overhead, and wolves trail behind, all moving together in a seasonal wave that ripples across the north. And as the land continues to warm, other animals join their own patterns of movement, guided by Earth's patient turning from season to season. Turtles nest by moonlit tides, guided by rhythms older than any coastline. Female sea turtles return to the very beaches where they hatched, sensing magnetic cues and the soft pull of rising tides. Under the quiet glow of the moon, they crawl ashore, leaving curved tracks across cool sand. Each movement is slow and deliberate, shaped by instinct refined over millions of years. They dig with patient sweeps of their flippers, creating a chamber where eggs can rest in warm, protective layers of sand. The tide whispers nearby, and stars shimmer overhead as the turtle covers her nest before slipping back into the sea. The eggs will incubate for weeks, warmed by shifting sunlight and cooled by night breezes. And when the season turns, another animal emerges into the spring air, bears waking to scents, carried through forests, softened by the first hints of warmth. Bears wake to spring scents after months of metabolic stillness, their bodies slowly rising from deep torpor as daylight lengthens and temperatures climb. They emerge cautiously from dens carved into hillsides, hollow logs, or rocky caves, blinking into soft morning light that feels unfamiliar after winter's long darkness. Spring air carries signals of change, thawing earth, running water, fresh shoots pushing through soil. Bears inhale these scents deeply, recognizing food sources that will restore their strength. Roots, berries, insects, and the occasional early fish. Their movements are unhurried at first, each step reconnecting them with the world outside. Forests respond alongside them, humming with insects and rustling with small animals. And beyond land, far offshore, whales follow their own seasonal cues, traveling gentle ocean highways shaped by shifting currents and ancient migratory paths. Whales travel gentle ocean highways formed by seasonal changes in temperature, food availability, and deep-sea currents. These massive animals navigate thousands of miles with quiet grace, sensing subtle gradients in water chemistry and using Earth's magnetic field like a map. In cold regions, nutrient-rich waters swell upward, drawing whales to feed in calm, rhythmic cycles. As winter approaches, they migrate toward warmer seas, where their calves can be born in sheltered, temperate waters. Their slow, powerful movements ripple through blue depths, accompanied by songs that travel farther than any sound on land. Light filters through the water in shifting colors, turquoise in summer shallows, deep indigo in winter currents. These seasonal journeys link entire ocean basins, shaping ecosystems around them. And in freshwater habitats closer to shore, amphibians begin responding to their own seasonal signals, returning to ponds that form with spring's first rains. Amphibians return to seasonal ponds as spring moisture seeps into the land, filling depressions and low-lying areas that remained dry through winter. Frogs, salamanders, and toads awaken from hibernation when soil warms, following familiar scents and vibrations toward temporary pools that serve as nurseries for the next generation. Rainfall deepens these ponds, creating calm surfaces that shimmer beneath early sunlight. Amphibians deposit eggs in gelatinous clusters, which gently sway among reeds and grasses. As temperatures rise, tadpoles hatch and drift in slow movements, feeding and growing within these seasonal waters. The ponds gradually warm, supporting insects, birds, and small mammals that follow the moisture. Yet as summer advances, many of these pools fade, absorbed by drying ground. This shift mirrors the adaptations of creatures in harsher climates, where desert animals must rest through heat to survive the extremes of their own seasonal cycles. Desert animals rest through heat by retreating into burrows, shaded rock crevices, and underground tunnels where temperatures remain far cooler than the sunlit surface. As daytime heat builds, the desert becomes a shimmering landscape of rising air and silent dunes. Many animals, foxes, rodents, reptiles, slow their body activities, entering brief torpor to conserve energy and water. Some emerge only with the dusk, when shadows lengthen and cool air spreads across the sand. Their movements are careful and quiet. Lizards leaving faint trails, owls gliding low, insects rustling through sparse vegetation. These patterns follow seasonal cues as well as summer heat, driving deeper retreats, cooler winter days allowing more activity. Life in the desert depends on these rhythms, shaped by Earth's turning and the delicate balance between sun, sand, and the creatures who endure by moving in harmony with the season's gentlest signals. Some cycles move slowly, shaping seasons across many years. El Niño warming spreads across oceans when trade winds weaken, allowing warm surface water to drift eastward like a vast, gentle tide rolling toward distant shores. This shift alters weather patterns around the world, softening rainfall in some regions while bringing heavier storms to others. The ocean surface glows with higher temperatures, releasing moisture into the air that drifts across continents as calm, persistent humidity. Fishermen notice changes first, currents shifting, fish moving deeper, the sea taking on an unusual warmth that lingers for months. Clouds gather differently, stretching into long silver bands over tropical waters. Landscapes thousands of miles away feel the influence of this slow-moving warmth, revealing how deeply connected Earth's systems are. And when the warm phase fades, the ocean begins preparing for its opposite cycle, when La Niña returns with cooling currents that strengthen trade winds once more. La Niña cooling strengthens trade winds, pulling warm water back toward the western Pacific and allowing colder, nutrient-rich water to rise along coastlines. This shift breathes new life into marine ecosystems, awakening plankton blooms and attracting fish in swirling, glittering masses. The ocean's surface cools noticeably, smoothing into deeper blues beneath clearer skies. Stronger trade winds guide clouds westward, altering rainfall patterns across continents, bringing heavier monsoons to some regions and long dry seasons to others. Weather becomes sharper, more defined, shaped by the contrast between warm and cool waters. And as La Niña settles in, the atmosphere begins adjusting its long-term rhythm, preparing for cycles that last far beyond a single season, such as the Pacific Decadal Oscillation that moves even more slowly across the ocean's vast expanse. The Pacific Decadal Oscillation shifts climate zones over spans of decades, warming and cooling the North Pacific in long, gentle phases that reshape regional weather far more quietly than individual storms. In its warm phase, sea surfaces brighten with higher temperatures, nudging winter storms toward new paths and softening coastal climates. In its cool phase, darker waters rise, bringing nutrients that feed marine life and redirecting atmospheric currents across continents. These changes unfold gradually, like a tide moving too slowly for the eye to catch, yet affecting rainfall, snowfall, and even forest growth over years. The oscillation forms patterns that echo through fisheries, agriculture, and ecosystems across the Pacific Rim. And as these great water masses shift, the Atlantic begins its own slower dance, with oscillations that influence storms traveling across the ocean toward distant shores. Atlantic oscillations influence storms by adjusting sea surface temperatures and atmospheric pressure patterns across the ocean basin. When the Atlantic warms, hurricanes may strengthen as they draw energy from the heated water, spinning across open seas with broad, slow-building power. Cooler phases soften these storms, guiding them along calmer paths or reducing their intensity. These oscillations affect rainfall in Europe, drought patterns in Africa, and even winter snowfall in North America. Warm currents shimmer beneath migrating birds, while cold currents darken into steel-blue swirls that alter marine food webs. Year after year, these shifts create subtle but far-reaching rhythms that shape coastlines and weather systems. And beyond these oceanic cycles, another ancient pattern continues: monsoon cycles, repeating across centuries, guiding entire civilizations with their dependable rise and retreat. Monsoon cycles repeat across centuries, with steady, predictable motion driven by the contrast between land heating quickly under summer sunlight and oceans warming more slowly. As continents heat, rising air draws moist winds inland, forming towering clouds that release rain in rhythmic pulses. These rains fall across valleys, farmlands, and forests, nourishing crops and feeding rivers that sustain millions of lives. When winter arrives, the pattern reverses. Cooler land pushes air outward, bringing dry, crisp months that allow fields to rest. Archaeological records and ancient texts show that these cycles have guided planting, migration, and culture for thousands of years. The monsoon's breath is long and patient, with subtle variations from year to year, yet a deep reliability over centuries. And as these vast atmospheric patterns continue unfolding, even slower cycles begin shaping climates on geological timescales. Ice ages advance slowly, reshaping continents with movements too gradual for any single lifetime to perceive. As global temperatures fall, snow that once melted each summer begins to linger, compacting into ice that thickens year after year. Glaciers form across northern landscapes, pressing forward like vast, silent rivers of frozen light. These sheets grind mountains into smooth valleys and scatter rocks across plains in calm, unstoppable motion. Oceans cool, winds shift, and coastlines redraw themselves beneath lowered sea levels. Yet even in their coldest moments, ice ages leave pockets of life: forests retreating southward, animals adapting to harsh winters, grasses bending beneath pale sunlight. Over tens of thousands of years, these frozen eras rise and fade like slow tides. And when the ice retreats, warmth returns with equal gentleness, spreading across the world in long, patient waves known as interglacial periods. Interglacial warmth spreads gently as Earth emerges from deep cold, allowing temperatures to rise slowly and melt the great ice sheets that once covered continents. Sunlight becomes stronger at higher latitudes, oceans release stored heat, and atmospheric patterns shift toward milder winds and wetter climates. Forests advance northward, grasses flourish, and rivers swell with meltwater that carries nutrients across newly exposed land. Sea levels rise gradually as glaciers shrink, reshaping coastlines with quiet persistence. Animals expand their ranges, mammoths giving way to deer. Woolly species replaced by those suited to greener, warmer habitats. These warm intervals last thousands of years, supporting human migration, agriculture, and cultural growth. But even within these stable climates, some regions transform dramatically over millennia, especially deserts whose boundaries wander in response to subtle planetary rhythms. Desert climates wander over millennia. As rainfall patterns shift, winds change direction, and long-term temperature cycles evolve. Areas that are now vast sand seas were once grasslands dotted with lakes, while regions lush today may have been dry plains in ancient eras. These changes occur as Earth's orbit, tilt, and ocean temperatures influence the movement of monsoons and trade winds. Sands drift slowly, sculpted by gentle but persistent breezes into dunes that migrate inch by inch across the landscape. Vegetation appears and disappears in response, leaving behind fossil pollen and ancient riverbeds that reveal past climates. Animals adapt by moving with these shifting boundaries, following water sources as they expand and retreat. And as deserts shift, forests respond too, their great belts rising and falling across continents under the influence of slow global cooling. Forest belts shift with slow cooling as temperatures fall over centuries, encouraging some tree species to migrate toward warmer regions while others expand into newly chilled zones. Boreal forests inch southward during colder eras, their conifers creating dark, quiet expanses across once temperate lands. Deciduous forests retreat gradually, leaving behind pockets where autumn colors fade earlier each year. These adjustments happen through generations of seeds traveling on winds, rivers, and migrating animals, forming new ecosystems over time. Cooler climates also influence soil moisture, snow cover, and growing seasons, shaping where plants can root and thrive. Birds, mammals, and insects follow the forest's slow motion, altering migration routes and habitats. And as vegetation shifts across continents, another subtle transformation unfolds, sea levels rising and falling in long arcs that mark Earth's rhythmic exchange between water and ice. Sea levels rise and fall in long arcs driven by the planet's glacial cycles, ocean temperatures, and shifting continental ice. When climate warms, melting ice adds water to the oceans, lifting shorelines upward in movements so slow they resemble the earth breathing. Waves reach farther inland, carving new bays, nourishing wetlands, and surrounding ancient cliffs. In colder eras, water returns to ice, lowering seas, and revealing wide coastal plains now hidden beneath modern oceans. These gradual rises and falls shape human migration, animal pathways, and the sediment patterns that sculpt coastal ecosystems. Coral reefs grow or retreat with the rhythm of these changes, forming layered histories beneath clear tropical waters. Through each cycle, Earth's coastlines rewrite themselves softly, connecting the vast movements of climate with the smallest grains of sand carried by tides. Even the stars and planets shape Earth's longest rhythms. Milankovitch cycles alter sunlight distribution through slow, predictable shifts in Earth's orbit, influencing how much solar energy each hemisphere receives across tens of thousands of years. These cycles gently guide ice ages, interglacial warmth, and long-term climate patterns. The changes are subtle, slight adjustments in Earth's orbit that soften or intensify seasons with barely noticeable annual effect. Over millennia, sunlight patterns drift like faint strokes of cosmic paint, shaping the growth of forests, the spread of deserts, and the rise and fall of ancient ecosystems. Snowfields expand when sunlight weakens, oceans warm when light becomes stronger, and landscapes adapt in their own quiet ways. As these orbital patterns continue, another slow cosmic motion unfolds above us: precession, the gradual wobble of Earth's axis that shifts the timing of seasons with patient precision. Precession slowly shifts seasons by causing Earth's axis to trace a gentle circle over roughly 26,000 years, altering when each hemisphere receives its strongest sunlight. This wobble changes the alignment between solstices, equinoxes, and Earth's position in its orbit, meaning that over long stretches of time, Summer may eventually occur closer to the point where Earth is nearest the Sunday. The shift is so gradual that no single generation feels its effects. Yet across ages, it subtly reshapes climate patterns and seasonal timing. Ancient skies looked different too. Constellations that marked seasons thousands of years ago no longer align the same way today. This celestial drift is a reminder of Earth's quiet motion within the solar system, and it forms part of a larger orbital rhythm influenced by eccentricity, the changing shape of Earth's path around the Sunday. Eccentricity changes Earth-Sun distance by altering the shape of our orbit from nearly circular to slightly elongated over cycles lasting around 100,000 years. When the orbit becomes more elliptical, seasonal contrasts can grow stronger, winters cooler, summers warmer, depending on how sunlight aligns with Earth's tilt. When the orbit becomes rounder, seasons soften into gentler patterns. These shifts don't cause sudden climate changes. Instead, they unfold slowly, blending into geological time, like long, quiet tides. Ice sheets respond across millennia, expanding or retreating as sunlight varies subtly. Deserts shift their boundaries, forests advance or withdraw, and coastlines adapt to the long arc of climate transformation. And while eccentricity reshapes the background rhythm of Earth's climate, another orbital factor, axial tilt, drifts as well, guiding the landscape's slow dance between warmth and cold. Axial tilt drifts over millennia, changing by only a few degrees but altering how sunlight falls across Earth's surface. When the tilt increases, seasons become more pronounced. Warmer summers, colder winters. When the tilt decreases, seasonal contrasts soften, creating milder climates. This slow adjustment happens over 41,000 years, too gradual for humans to perceive, but powerful enough to influence the rhythm of ice ages and interglacial warmth. Forests, grasslands, and marine ecosystems adapt to the long-term light shifts, reshaping patterns of growth and migration. Sunlight angles change subtly, altering how shadows stretch across mountains and how warmth spreads across oceans. Animals follow these faint cues through generations, adjusting behaviors in ways that reflect ancient memory. As Earth's tilt drifts, the sun's influence also changes through its own cycles, sending variations in energy that ripple through the atmosphere. Solar cycles affect atmospheric patterns, as the sun's energy output rises and falls in roughly 11-year intervals. These cycles influence the number of sunspots on the solar surface, which correlate with changes in ultraviolet radiation and the strength of the solar wind. When solar activity increases, Earth's upper atmosphere expands slightly, altering how energy flows through layers of air. Subtle shifts in jet streams, storm frequency, and temperature patterns can ripple through continents. Auroras brighten across polar skies, shimmering in curtains of green and violet. During quieter solar periods, the atmosphere cools and contracts, softening these effects. Life on Earth doesn't feel these rhythms day by day, yet ecosystems and climate systems reflect them across decades. And beyond solar cycles lie even deeper astronomical influences that connect Earth's climate to the slow choreography of the cosmos. Lunar tides guide coastal life with a steady rhythm shaped by the moon's gravitational pull. As the moon drifts across the sky, it draws ocean water toward it, lifting tides that rise and fall with soft, predictable motion. Countless species depend on these cycles. Crabs scuttle along wet sand during low tide, fish feed in tidal pools, and sea turtles sense the changing water levels as signals for nesting. The pull of the moon is gentle yet powerful, shaping currents, stirring nutrients, and balancing the daily breathing of the shoreline. At night, Moonlight glimmers across retreating waves, revealing rippled sand and scattered shells. When the tide returns, it smooths everything again, like a hand brushing over silk. And while the moon guides these coastal rhythms, its influence blends with even broader forces, planetary alignments that subtly affect the pull between Earth, Sun, and the other worlds drifting through space. Planetary alignments affect orbital pull by creating tiny gravitational nudges that shift Earth's motion in ways far too subtle to feel in everyday life. When large planets like Jupiter and Saturn align with Earth and the Sun, their combined gravity tugs faintly on Earth's orbit, altering its shape or tilt over long timescales. These changes never happen suddenly. Instead, they unfold like whispers across millennia, nudging climate patterns, ocean cycles, and the long arc of seasonal timing. Astronomers track these alignments to understand how they shape deep climate history, including the pacing of ice ages. Even though the pull is slight, the combined effect accumulates, guiding Earth's orbital dance with cosmic patience. And as planets influence the motion of our world, even smaller particles drifting through space, tiny grains of cosmic dust enter Earth's atmosphere, adding their own quiet signature to the planet's surface. Cosmic dust enters Earth's atmosphere in a constant, delicate drizzle, arriving from comets, asteroids, and distant stellar debris. As these tiny particles drift downward, they burn softly in the upper atmosphere, creating faint streaks of light invisible during the day, but shimmering as meteors at night. Some dust survives the fall, settling onto oceans, forests, and ice sheets, in layers too thin to notice. Yet these microscopic grains carry minerals that enrich ecosystems and help seed cloud formation high in the sky. Over centuries, dust accumulates in soils, snowfields, and ocean floors, preserving a cosmic record of Earth's journey through the solar system. And within these drifting particles, charged solar energy also plays a role. Solar wind sweeping through space and shaping the upper layers of Earth's atmosphere with soft, persistent currents. Solar wind shapes the upper air by carrying charged particles from the Sun that interact with Earth's magnetic field. When these particles reach the atmosphere, they compress and stretch the magnetosphere, influencing how energy flows through the ionosphere and affecting long-distance radio signals, auroras, and even global circulation patterns. The northern and southern lights glow with soft curtains of green, pink, and violet as solar wind collides with atmospheric gases. These gentle storms in the upper atmosphere ripple slowly, far above the weather systems we see from the ground. Although solar wind does not alter daily climates directly, its influence accumulates over time, shifting atmospheric chemistry and guiding subtle long-term trends. And as solar energy shapes the sky, Earth's surface receives a quieter gift: meteoritic material settling into soil, enriching it slowly through deep time. Meteoritic material feeds fertile soils as microscopic fragments of space rock accumulate across the planet. Each day, thousands of tiny particles settle onto Earth. Iron, nickel, silicates, and rare elements scattered like cosmic dust across fields, forests, and oceans. Over millennia, these minerals blend into soil layers, providing nutrients that influence plant growth and microbial activity. Some meteorites deposit larger concentrations of metals, becoming part of ancient landscapes that later humans discover and shape. Rain and wind carry these cosmic traces into rivers and lakes, weaving them into Earth's natural cycles. Though small in amount, this steady cosmic contribution reminds us that Earth is never isolated. It receives gifts from the solar system with quiet regularity. And with this final influence, the chain of astronomical forces shaping Earth's climate, soil, and seasons completes its gentle arc. The ground beneath us transforms gently as seasons pass. Soil warms layer by layer when spring sunlight returns, sinking slowly into the earth as if the warmth is being poured downward in soft, patient waves. The topsoil heats first, loosening after months of winter stillness, releasing the smell of minerals, rain, and new life. Microbes awaken in tiny bursts of activity, turning last year's leaves into nutrients. Roots sense the temperature shift and begin drawing water upward with renewed strength. As each layer warms, earthworms move closer to the surface, threading through the soil in quiet motion. The warmth spreads deeper over weeks, shaping the pace of seed germination and the unfolding of early plants. And just as the soil responds to rising temperatures, the rocks within it begin their own subtle reaction to seasonal change, expanding and contracting with a rhythm almost too slow to feel. Rock expands and contracts subtly as temperatures shift, responding to seasonal changes with movements that are small yet constant. In summer, heat causes rock surfaces to swell microscopically, opening fine cracks and widening existing fractures. When winter arrives, cooling air tightens these surfaces again, contracting minerals and compressing layers back into place. Over countless cycles, this gentle breathing of stone shapes cliffs, boulders, and mountainsides, slowly wearing them down into grains that join the soil. Frost adds its touch as water seeps into cracks and freezes, expanding with quiet pressure that smooths rugged edges. These gradual transformations create patterns on canyon walls, scattered talus slopes beneath ridges, and sand that begins as fragments of ancient stone. And as rocks break down over time, they form the foundation for landscapes shaped further by wind, especially in deserts where sand dunes shift with seasonal breezes. Sand dunes shift with seasonal winds that sculpt their curves into ever-changing shapes. In summer, warm air rising across deserts creates steady winds that push sand grains upward along dune faces, lifting them in tiny hops before letting them settle over the crest. In winter, cooler winds arrive from different directions, smoothing sharp edges and drawing ripples across the surface, like patterns brushed into soft fabric. Each grain moves independently, yet together they form dunes that migrate slowly across open plains, reshaping the land with rhythm and patience. Plants at the edges anchor small portions, creating pockets of stability where animals leave fleeting tracks at dawn. Storms bring bursts of stronger wind, carving deeper ridges, while calm days allow dunes to rest in quiet symmetry. And beyond the deserts, in regions where ice dominates instead of sand, glaciers begin their own slow movement, advancing and retreating with the change of seasons. Glaciers advance and retreat as seasonal temperatures guide their slow, powerful motion. In colder months, snowfall accumulates on high mountain slopes, compressing into dense ice that adds weight to the glacier's upper layers. Gravity pulls this mass downward, allowing the glacier to slide imperceptibly across rock, carving valleys and polishing surfaces into smooth, glistening forms. When warmer seasons arrive, the glacier's lower edges melt, releasing streams of clear, icy water that feed rivers winding through distant forests and plains. The balance between snowfall and melting determines whether a glacier grows or shrinks, shifting its shape across decades and centuries. Ancient layers of ice hold air bubbles that preserve whispers of past climates, chronicling ages long gone. And while glaciers sculpt landscapes with icy persistence, volcanoes shape them with heat, creating surfaces that cool slowly and transform under the steady influence of seasonal weather. Volcanic landscapes cool slowly after eruptions, responding to seasonal changes in temperature, rain, and wind, long after lava stops flowing. Fresh rock begins as glowing, molten rivers that harden into dark, glassy surfaces, radiating heat into the air for months. Over time, rainfall seeps into cracks, steaming gently as it meets the lingering warmth below. Sunlight warms the rock differently through the year, intense in summer, faint in winter, gradually altering its color and texture. Small plants appear first. Mosses, hardy grasses, and tiny flowers rooting in ash-rich soil created by volcanic minerals. Winds push dust into crevices, helping new layers of soil form. As the seasons cycle, these barren landscapes soften, gaining subtle contours and pockets of life. And through all these changes, Earth's surface continues its quiet evolution, shaped by forces that move with patience beyond anything we see day to day. River deltas grow with spring melt as mountain snow and ice release vast pulses of fresh water that carry sediment downstream. These sediments, tiny grains of rock, minerals, and organic material, drift through winding rivers until slowing currents near the coast allow them to settle. Layer by layer, deltas extend outward into quiet bays and shallow seas, forming new land in soft, branching patterns that resemble roots spreading through water. As spring intensifies, freshwater shapes, channels, shifting sandbars, and nourishing marsh grasses that anchor the delta's edge. Fish move inland with the rising flow, and birds gather in shimmering flocks along newly flooded wetlands. When meltwater finally eases, the delta rests beneath calmer tides, holding the imprint of the season's transformation. And along coastlines shaped by these changing waters, storms arrive with their own force, subtly shifting the outlines of shores and beaches. Coastal shapes shift with storms as waves and winds rearrange sand, rock, and vegetation in sweeping motions. Powerful winter storms can carve cliffs and pull beaches back toward the sea, while gentler summer swells return sand in delicate, rolling layers. Each coastline becomes a living boundary, constantly redrawn by tides, currents, and seasonal weather. Storm surges shape dunes, flattening some areas while piling sand elsewhere. Salt spray settles inland, feeding hardy plants that cling to shifting ground. After storms pass, the coast enters a calmer phase, water settling into rhythmic waves, sunlight glinting across reformed shorelines. Marine life adjusts quickly, moving with new channels and tide pools. And just inland from these ever-changing borders, wetlands begin their own seasonal process of breathing, absorbing and releasing water as the year slowly unfolds. Wetlands breathe through wet and dry phases, expanding when seasonal rains arrive and contracting when heat returns. These ecosystems act like natural sponges, soaking up water and releasing it slowly, creating shifting mosaics of pools, grasses, and shallow streams. In wet seasons, wetlands come alive with birdsong, amphibians, and the hum of insects exploring fresh water. Plant roots filter sediments, cleansing the water before it spreads into wider channels. During drier months, water retreats into deeper pockets, leaving cracked mud patterns that hold the memory of earlier floods. Many species synchronize their life cycles to these rhythms, fish spawning in flooded areas, birds nesting along reed beds, and mammals following the availability of water. These gentle expansions and contractions mirror changes happening at higher elevations, where mountain forests rise and fall with the shifting boundaries of winter snowlines. Mountain forests rise and fall with snowlines that advance in winter and retreat in spring, shaping the lives of plants and animals along steep slopes. As snow blankets upper elevations, animals move downward to find food while evergreen branches bow beneath accumulating weight. Beneath the snowline, deciduous trees stand bare, conserving energy until warmer days arrive. When temperatures climb, the snow line begins to ascend, uncovering mosses, young shoots, and moist soil that nourishes spring growth. Wildflowers burst into color along newly exposed ridges, while meltwater streams carve fresh paths through forests. This vertical migration of seasons creates distinct habitat zones that shift gently throughout the year. And as warmth expands upward, dry regions elsewhere anticipate another rare transformation, deserts blooming briefly after unexpected, life-giving rains. Deserts bloom briefly after rare rains, transforming barren landscapes into vibrant carpets of color for just a short moment each year, sometimes only once in several years. Seeds that have waited dormant beneath scorching sand absorb the sudden moisture and awaken almost immediately, sending shoots upward into warm air. Within days, fields of wildflowers stretch toward the horizon, painting dunes and rocky plains in shades of violet, gold, and crimson. Insects arrive quickly, followed by birds and small mammals drawn to the newly available nectar and seeds. This burst of life is fueled by efficient plant strategies. Rapid growth, minimal leaves, and deep roots that capture water swiftly. As heat returns, blossoms fade, petals drift away, and the desert returns to stillness. Yet the memory of moisture remains in seeds carried by wind and sand, waiting patiently for the next cycle to begin. The year unfolds like a slow wave, rising and falling in gentle arcs that sweep across the landscape with steady rhythm. Each month brings a subtle shift: longer light, softer winds, deepening shadows, changes so gradual they seem almost still when viewed day by day. But step back, and the pattern becomes clear. Earth inhales warmth and exhales coolness in cycles as old as time. Temperature curves rise slowly through spring, crest in summer's broad brightness, then fall in a measured decline toward winter's quiet. Plants, animals, oceans, and even the atmosphere respond to this progression with their own calm adjustments. Forests thicken, rainfall drifts, cloud shapes shift, and as the crest of this yearly wave begins to sink, light changes first, deepening gently into winter rest. Light deepens into winter rest as the sun lowers its arc across the sky, illuminating the world with softer, cooler rays. Days shorten, stretching shadows long across fields and quiet streets. Because sunlight travels through more atmosphere, its warmth weakens, transforming bright summer glare into pale winter glow. This muted light slows plant growth, nudges animals toward stillness, and creates calmer winds as surface heating decreases. Snow reflects the faint sunlight, adding a subtle brightness that seems to rise from the ground rather than fall from above. Indoors, light pools in warm tones as windows collect the angled rays. Everything feels quieter under winter's softened illumination, as if the world is pausing for a long, restorative breath. But just beneath this stillness, the first signs of change begin preparing to rise again. Spring lifting the world with warmth. Spring lifts the world with warmth as sunlight strengthens and days begin lengthening once more. The increased energy from the sun warms soil, melts lingering snow, and awakens plants that waited through winter's calm. Buds swell with quiet determination. Birds return with soft bursts of song, and rivers loosen their icy grip. Air temperatures climb steadily, though gently, inviting early blossoms to open in cautious shades of pink, white, and yellow. Morning light glimmers on new leaves, creating a soft green haze that spreads through forests. The atmosphere becomes more active. Two warmer surfaces generate rising currents, forming clouds that drift across skies freshly washed by rain. Spring's warmth does not rush. It expands in slow pulses, like a promise unfolding. And as this growing energy carries the world forward, the season opens fully into summer, which expands into long days filled with broad, generous light. Summer expands into long days as the sun reaches its highest path, bathing Earth in bright, sustained warmth. Daylight stretches gracefully into evening, giving landscapes a lingering glow that settles gently over fields, forests, and coastlines. Temperatures rise steadily, energizing plants and encouraging rapid growth. Leaves thicken into deep canopies that sway in rhythmic breezes, while grasses ripple in long, shimmering waves as heat gathers above the ground. The atmosphere responds with rising warm air that fuels towering summer clouds, casting wide shadows that drift slowly across the land. Nights cool only slightly, holding the memory of sunlight in warm, scented air. Animals thrive in this abundance, moving with confidence through well-lit hours. Yet as summer reaches its height, a quiet shift begins. Light softens, breezes cool, and autumn starts gathering gold and quiet. Autumn gathers gold and quiet as sunlight weakens and temperatures ease downward, inviting leaves to release their hidden pigments in warm cascades of amber, red, and rust. Days shorten gently, bringing cooler evenings that settle softly over hills and fields. The atmosphere becomes clearer, allowing distant mountains to appear sharper, their outlines edged with crisp autumn air. Forests glow under low-angle sunlight, each leaf illuminated as though held briefly in a warm, golden flame. Animals prepare for winter. Squirrels stash food, birds form migrating flocks, insects seek shelter in tree bark and soil. Winds shift too, carrying the scent of ripe fruit, dry grass, and cooling earth. Autumn's quiet is not emptiness, but a soft pause, a moment of balance between the fullness of summer and the stillness to come. And as its colors fade, the annual cycle moves gently toward its next beginning. Animals sense seasonal shifts through a combination of daylight length, temperature changes, and subtle environmental cues that signal the world is turning toward its next phase. Birds grow restless as days shorten, feeling an ancient pull to migrate. Deer shed summer coats and grow thicker fur as the air cools. Even tiny insects respond. Monarch butterflies tilt their bodies toward the sun, reading its angle like a compass. Hormonal changes sweep through entire ecosystems, guiding behavior with quiet precision. Creatures adjust feeding patterns, movement routes, and nesting habits without hesitation, as if reading lines written across the landscape. These instincts form a soft choreography repeated year after year. And while animals prepare for change externally, plants respond internally, storing energy in deeper rhythms that carry them through seasons of rest and renewal. Plants store energy in deeper rhythms as days shorten, guiding sugars produced in brighter months into roots, bulbs, and thickened stems. This internal shifting prepares them for winter's quiet, when sunlight weakens and growth slows almost to stillness. Leaves fade and fall, allowing trees to conserve water and protect delicate tissues from freezing. Underground, roots continue slow metabolism, drawing minerals and moisture into hidden chambers that hold life in suspended calm. Perennial plants retreat into soil, where their energy waits in tightly wound buds, each one a promise of spring. Even evergreens adjust, strengthening cell walls and conserving nutrients. These subtle changes happen gradually, almost invisibly, guided by light and temperature. As plants settle into their seasonal rest, the world above them shifts too, skies changing color with temperature, reflecting the atmosphere's own gentle transition. Skies change color, with temperature as light interacts with shifting particles, moisture, and air density throughout the year. Cold air in winter scatters sunlight more efficiently, creating crisp blue days and pale pastel sunsets that stretch softly across the horizon. In summer, warmer air holds more moisture and aerosols, deepening sky tones into richer blues and glowing gold at sunrise and sunset. Spring mornings often appear hazy with new humidity, while autumn skies carry warm amber light, shaped by drying leaves and drifting dust. These seasonal variations tell stories of air in motion, expanding, contracting, absorbing, and releasing warmth with delicate precision. Clouds take on different hues as well, reflecting the temperature of the layers they pass through. As skies shift, winds follow, responding to pressure changes that develop as the atmosphere resets itself for the next turning of the year. Winds turn as pressure balances reset, flowing from regions of high pressure to low pressure in slow, graceful movements that signal the seasons changing. In winter, strong contrasts between cold land and warmer oceans create brisk winds that sweep across open fields. Spring brings variable breezes that swirl gently as rising temperatures reshape atmospheric layers. Summer winds soften, guided by warm air rising from the ground and cooler air slipping in to replace it. Autumn winds sharpen again, scattering leaves and carrying the scent of rain or distant fires. These turning winds help distribute heat, moisture, and seeds across landscapes, influencing weather patterns and shaping ecosystems. The atmosphere adjusts constantly, never still, yet always returning to balance. And through these shifting winds, Earth prepares once more to repeat its grand design, its cycle unfolding with gentle certainty year after year. Earth repeats its cycle with gentle certainty, turning steadily through seasons that have guided life for billions of years. Each orbit around the sun brings familiar patterns: warming, cooling, budding, blooming, resting, that anchor ecosystems in quiet predictability. The planet tilts, leans, and circles without haste, carrying continents, oceans, forests, and skies through their soft choreography. Seasonal light drifts across landscapes, shaping migrations, flowering, rainfall, and the pulse of winds. Even the smallest organisms move in harmony with these rhythms, sensing signals we rarely notice. Though each year is unique, the broader cycle remains steady, offering comfort in its reliability. Time flows outward in peaceful spirals. Winter to spring, spring to summer, summer to autumn, autumn back into winter. And with every return, Earth's calm promise remains: the world will warm, cool, change, and renew, following its ancient rhythm with enduring grace. As we reach the end of this journey through Earth's gentle rhythms, let yourself settle into the same quiet certainty that guides the turning of the seasons. Everything we've explored tonight, every changing breeze, every drifting cloud, every migrating creature and unfolding leaf, moves according to patterns so patient, so steady, that they almost become a kind of universal lullaby. These shifts happen not with sudden motion, but with a softness shaped by sunlight, temperature, and the slow choreography of the planet itself. The world changes around you in ways that are almost imperceptible moment to moment, yet astonishing when viewed across a year. Spring rises from winter's rest in small, warm breaths. Summer expands like a long-held note of brightness. Autumn gathers gold and lets it fall gently back to the ground. And winter settles over everything with a calm that invites the earth to breathe more slowly. These cycles hold the memory of every age that came before us, repeating again and again with reassuring familiarity. Even deep beneath your feet, the planet responds to these rhythms. Soil warms in quiet layers. Water flows in patient streams from mountain snow. Forests shift their colors with exquisite timing, as if responding to a conductor only they can hear. And above all of this, the sky changes its hues from the crisp blue of winter to the hazed gold of summer, reflecting the temperature of the air and the tilt of the sun as Earth moves gently around its orbit. Creatures feel these cues in ways far older than memory. Birds sense when winds begin to change and carry themselves across continents. Amphibians wake when soil warms. Desert plants wait for a single rain before bursting into life. And tall trees, older than entire civilizations, feel the approach of winter and begin storing their energy in deeper rhythms, preparing for rest, just as humans once shaped their lives around the pulse of the seasons. The beauty of these cycles lies not only in their predictability, but in their softness, the way everything unfolds in slow, calm transitions rather than sharp edges. Seasons dissolve into each other. Light changes gradually. Winds turn with quiet purpose. Even storms, with their powerful energy, often leave behind a clarity that reveals just how resilient the planet is. Earth is always moving toward balance, always resetting its patterns, always preparing for the next turning. And through it all, you are part of these rhythms too. Your body rests more deeply in winter's cool nights. Your thoughts lighten in the expanding warmth of spring. Your energy rises and falls with sunlight, just as oceans swell and forests bloom. There is peace in aligning yourself with these natural cycles, in remembering that rest is as essential as growth, stillness as meaningful as motion. Tonight, as you drift toward sleep, imagine the year unfolding around you, not rushing, not demanding, simply flowing in its ancient, gentle arc. Feel the calm of winter's quiet light, the soft awakening of spring air, the generous brightness of summer, and the golden hush of autumn gathering everything close. These rhythms have shaped Earth for billions of years, and they will continue long after this moment. You are resting within a system that knows exactly how to renew itself. Nothing is hurried. Nothing is forced. Earth turns, tilts, warms, cools, and begins again every time with the same patient grace. So let the steadiness of the planet cradle you. Let the slow pulse of the seasons ease your breath. Let the calm of everything around you become the calm within you. Thank you for wandering through these cycles tonight. May the rhythm of the earth guide you gently into deep and peaceful sleep. Good night.